The PSA test, prostate-specific antigen test, can be used to screen mature men for prostate cancer. In this pamphlet, the sample space of all asymptomatic mature men who could be screened with the PSA test is modeled, represented with, simplified by this set of 100 men and the possible combinations of outcomes in terms of having prostate cancer or not and obtaining a positive or negative PSA test. We are told that for every 100 men who have a PSA blood test as part of screening, 10 will have an elevated PSA test result. So that's what we would call a positive test result. And 90 will have normal PSA levels. So that's what we would call a negative test result. The test results are further broken down into the combinations of positive and negative test and prostate cancer versus no prostate cancer. We can use the information from this model sample space to calculate a number of probabilities within this target population. First of all, what is the rate of prostate cancer in this population? This is the percent of men with prostate cancer in this entire sample space. So this is a general probability. Since the size of the sample space here is modeled by 100 men, then the denominator is going to be 100, and the numerator will be the total number of men with prostate cancer in this sample space. So we see that we have 3 green dots, the men who have prostate cancer and will get a positive test. We also have the 1 yellow dot corresponding to the 1 man with prostate cancer who will get an incorrect negative test. So that's 4 out of 100, that's a probability of 4%, 0.04. What is the sensitivity of the PSA test? That is, what is the probability that the test will come back positive, as it should, when the man has prostate cancer? So this is a conditional probability, which means that the denominator is not the entire sample space, but just a subset of men who have prostate cancer. And as we just identified, in this simplified sample space, we have 4 men with prostate cancer. So out of those 4 men, how many will get a positive test result? Those are the 3 green dots. So the sensitivity of the PSA test here can be computed as 3 out of 4, 75%. Likewise, to obtain the specificity of the PSA test, we are looking at a conditional probability where the subset of interest is all those men who do not have prostate cancer. So that's everybody except for those 4 with prostate cancer. So that's out of 96 in the denominator. And we want to know how many of them will receive a negative test result. And we can see that those are the 89 blue dots. And so 89 out of 96, that's 92.7%. Notice that the rate of prostate cancer is a fairly small probability value at just 4%, thankfully so. The sensitivity and specificity of the PSA test, on the other hand, are relatively large values at 75 and roughly 93% respectively, which is to be expected. We wouldn't want a tool that is wrong most of the time. So you would definitely want to have tests that have at least above 50% sensitivity and specificity. Potentially the most important question about the use of the PSA test is the positive predictive value. That is, what does a positive test tell you in probability terms? That is the probability that the man actually has prostate cancer if this man receives a positive test result. So this is again a conditional probability, which means that in our denominator, we're going to look only at the subset of men in this sample space who receive a positive test. So in the simplified model of the sample space, 10 men receive a positive PSA test. Out of those 10, how many actually have prostate cancer? And those are the 3 green dots. So 3 out of 10, that's 30%. That tells us that if a mature man who is screened with the PSA for prostate cancer receives a positive test result, then this man has 30% chance of having prostate cancer. It also implies that this man has 70% chance of not having prostate cancer. The probabilities we computed, such as in particular the positive predictive value, they tell us about the usefulness of those screening tests in terms of the information they provide. That is not the same as saying that the information will result in a net benefit in terms of health.